Hi, I'm Sherrie Conroy. I'm Director of Content with Medical Design Magazine. We're here today with Chris Sakezles, who's going to talk to us about the advances in the past year with SynDaver Labs and what's new, what's going on.
Okay. Well, over the last year, we've developed a new testing and training platform. We're calling it the SynDaver Synthetic Human. And it's essentially the culmination of the last 7 years of work we've done in the development of synthetic human tissue analogs. We got to the point now where we have a library of about 50 different tissues, and they're validated against live tissue in terms of properties like tensile modulus, puncture resistance, abrasion resistance, things of that nature. And we take those materials and we build human anatomy out of it. This can be anything from products as simple as skin fat plates to body parts to completely synthetic human bodies. And so our flagship product at this point is the synthetic human, and it's something that can be used as kind of a unified testing and training platform for not just medical device development, but the end use of medical products. So surgeons, clinicians, medical professionals will use the products that medical device engineers have developed, at the end use stage.
And what would you say has been the most interest at the show this year?
Well, we do a lot of different things, and the traffic we get at this show is mostly research and development engineers, people that work in that field. The new products we have, the discrete products we have that are of interest to those people have been some of the more complex vascular components. We make complete 4-chamber hearts now, aortic root valves, coronary arteries, really complex tracheas within individual hyaline cartilage rings, a lot of different things. Everything that resides in within normal human anatomy now is something that we produce, and not just in a healthy state but also disease states. So we make a whole variety of pathologies: vascular plaques, tumors, aneurysms, venous malformations, a lot of different things.
Can you talk a little bit about how your products are developed differently from other things that might be considered competitors?
Well, there are quite a few companies that make anatomical models, and the focus of all of those companies is invariably to make products that look like human tissue and human body parts. From a research and development standpoint, that's nonsense. It makes absolutely no difference if something looks like a body part. An R&D engineer cares about performance. And so we've taken the fundamentally different approach of developing tissues from the ground up. We actually start with a live tissue study for every analog that we have developed, and we validate our analogs against the live tissue on a number of mechanical, physical, chemical properties. So at the end of the day, we have this library of validated tissues that we can build human anatomy out of that just happens to look like the real thing.
Right.
It's by accident almost. The real focus of our technology is that it performs like the real thing, and that's what enables us to use this platform in the development life cycle.
Does that give them more accurate results as to how their product is going to perform?
It allows a whole new kind of device development testing. If a device engineer, aside from this technology, wants to test his device, he has to source a model. And the gold standard model in industry, has typically been the porcine model or some kind of animal model. Animals are readily available. There's a great deal of rigmarole, for lack of another word, you have to go through to make that happen. You end up with one data point at the end of the study, if you're lucky, that you don't have to try to explain away to the FDA. With our technology, you end up collecting 1,000 more data points for half the cost. It's a lot faster, it's a lot cheaper, and at the end of the day, you end up with data that isn't going to increase the length of your development cycle.
Right, that's great. Well, thank you very much. Would you like to show us some of what you've got out?
Sure. Well, this is the SynDaver Synthetic Human. It's been partially undressed. The the chest cavity has been split open, the abdominal cavity has been split open to reveal some of the internal structures. The skin's been taken off, but this kind of shows the level of detail that we have in the model. Every bone, muscle, tendon, vein, artery, and organ in the body is separately removable and replaceable. And at this point, what we have is essentially a unified platform that can be used from the very beginning of the medical device development life cycle all the way through to the end where physicians, practitioners are using the device to actually learn how to use them. The upper chest cavity is delineated by the collarbone and the diaphragm, and in here we have the heart with the coronary arteries, the upper section of the aorta, the superior vena cava, the trachea, the lungs. And on the lower half, in the abdominal section, we have all the normal visceral organs, complete GI tract from the esophagus to the rectum, stomach, both kidneys, spleen, everything that's in there.
Fascinating.
It's completely vascularized. The system comes with a heated heart pump that pumps pulse-style flow on the arterial side, drainage flow on the venous side, so you can treat both the arterial and the venous system.
I want to thank you for the tour. You want to let people know where they can find out more about what you have to offer?
Sure. Our website is located at www.syndaver.com. We have a complete e-commerce site. You can find out pretty much all the information you need to know there about our technology, how it's made. We do a lot of custom products as well, so if anybody's interested in that sort of thing, they would contact the company.
Great. Thank you very much.